Hi friends, welcome to the Abby's new tech video. Today we are discussing the second part of interview question in embedded system. Hope you all seen the first part video. If you find our channel is useful, please share with your friends. Let's start. First question. Explain about scheduling. An operating system kernel can suspend and later resume a task many times during its lifetime. That means the core function of a kernel is to share processor time among different concurrent tasks. The scheduler is the part of kernel responsible for deciding which task should be executing at any particular time. The way that time is allocated between tasks is termed as scheduling. The scheduling policy is the algorithm used by the scheduler to decide which task to execute at any point of time. Next question, what are the objectives of scheduling? First point, maximum CPU utilization. That means to keep CPU as busy as possible. Next point, fair allocation of CPU. Next point, maximum throughput. That means to maximize the number of processes that complete their execution per unit time. Next point, minimum turnaround time. That means to minimize the time taken by a process to finish the execution. Next point, minimum waiting time. That means to minimize the time a process waits in the ready queue. Next point, minimum response time. That means to minimize the time when a process produces the first response. Next question, preemptive scheduling. What is preemptive scheduling? We know each task may have different priorities. The scheduling in which a running process can be interrupted if a high priority process enters the queue and is allocated to the CPU is called preemptive scheduling. In this case, the current process switches from the running queue to ready queue and the high priority process utilizes the CPU cycle. Preemptive scheduling is flexible by allowing the critical process to access CPU as they arrive into the ready queue no matter what the process is executing currently. Next question. What is non-preemptive scheduling? In this scheduling, once the resources is allocated to a process, the process holds the CPU till it gets terminated or it reaches a waiting state. In case of non-preemptive scheduling, it does not interrupt a process running the CPU in middle of execution. Instead, it waits till the process completes its CPU best time and then it can allocate the CPU to another process. Non-preemptive scheduling is called a rigid, as if even if a critical process enters the ready queue, the process running CPU is not disturbed. Next question, what do you mean by mixed scheduling? From the term itself, we can understand that this schedule is a combination of preemptive scheduling and non-preemptive scheduling. In this type of scheduling, there are high priority processes that are scheduled in non-preemptive manner and there are low priority processes that are scheduled in preemptive manner. Next question, what is the difference between static and dynamic scheduling? In static scheduling, the system designer has analyzed the characteristics of each process and specified the exact order of process execution. During execution of real-time system, the order of scheduled process will not change. Then dynamic scheduling is the mechanism where thread scheduling is done by the RTS based on the selected scheduling algorithm. Execution order of thread is completely controlled by that algorithm. During execution of RTS, the order of scheduled process will constantly change. Next question, what is interrupt-based polling? An interrupt is a signal to the processor emitted by hardware or software indicating an event that needs immediate attention. In interrupt, the device notifies the CPU that it requires attention, whereas in polling, the CPU continuously checks the status of the device to find whether they require attention. In brief, an interrupt is asynchronous, where polling is synchronous. The interrupt is always more advantageous than polling because in interrupt the microcontroller can serve many devices based on the priority assigned to it. But in polling method, it cannot assign priority because it checks all the devices in a round robin fashion. Next question. What do you mean by interrupt handler? Whenever an interrupt occurs, the controller completes the execution of current instruction and start the execution of interrupt service routine or interrupt handler. The interrupt service routine tells the processor or the controller what to do when the interrupt occurs. For every interrupt, there is a fixed location in memory that holds the address of its interrupt service routine. Next question. What are maskable and non-maskable interrupts? When the signal for the processor is from an external device or hardware, that is called as an hardware interrupt. Maskable interrupts are those hardware interrupts which can be delayed when a much high priority interrupt has occurred at the same time. Whereas a non-maskable interrupt are the hardware interrupts which cannot be delayed and should be processed by the processor immediately. Next question. What do you mean by interrupt latency? Interrupt latency is the time that elapses from when an interrupt is generated to when the source of interrupt is serviced. Factors that affect interrupt latency include the microprocessor design, that means the microprocessor architecture, the microprocessor clock speed, then the particular OS employed, and the type of interrupt controller used. Next question. How can we minimize the interrupt latency? First point, keep the interrupt service routine simple and short. Second point, do not disable interrupts. Third point, avoid the instruction that increase latency. Fourth point, properly prioritize the interrupts. Next question. What do you mean by priority inversion? Priority inversion occurs when a high priority task is forced to wait for the release of a shared resource owned by a low priority task. Here, high priority task is indirectly preempted by a low priority task, effectively inverting the relative priority of two tasks. If the high priority task is left starved of the resource, it might lead to a system malfunction or the triggering of predefined corrective measures like watchdog timer resetting the entire system. Next question. What do you mean by priority inheritance? Priority inheritance is a solution for the priority inversion. The basic idea of priority inheritance protocol is that when a job blocks one or more high priority jobs, it ignores its original priority assignment and executes the critical section of low priority task at an elevated priority level. After executing its critical section and releasing its log, the process returns to its original priority level so that the high priority task can start executing. Next question. What do you mean by atomic operations? Atomic operations are those operations that finish their task as a whole, that is, no other interruption is allowed before its completion. An atomic operation is an operation that always be executed without any other process being able to read or change the state, that is, read or changed during the operation. It is effectively executed as a single step and is an important quality in a number of algorithms that deal with multiple independent processes. Next question. What do you mean by critical section? In concurrent programming, concurrent access to shared resources can lead to unexpected error. So part of the program where the shared resource is accessed need to be protected in a way that avoid the concurrent access. This protected section is the critical section or critical region. An atomic action is required in a critical section, that is, only one process can execute in its critical section at a time. All other processes have to wait to execute in their critical sections. Next question. What do you mean by reentrant function? A function is said to be reentrant if there is a provision to interrupt the function in the course of execution, service the interrupt service routine. Then it will resume the early going function without hampering its earlier course of action. Reentrant functions are used in applications like hardware, interrupt handling, recursion, etc. Next question, what are the conditions for reentrancy? First condition, it may not use global and static data because the interrupt may change certain global values and resuming the course of action of the reentrant function with the new data may give undesired result. Second point, it should not modify its own code. This is important because the in course of action of the function should remain the same throughout the code. Last point, should not call any other non-reentrant function. Okay friend, that's all for this time. We'll meet you all in next class with the continuation video. Stay tuned. Thank you all.